Hey guys, in this video we are going to continue writing quadratic equations, but the process that we're going to take is going to be different because the information that we're given is different. This time they're going to be giving us the vertex of the parabola and a point on the parabola, and it's going to be our task to write an equation in vertex form. So let's look at a couple examples to see how we would complete this task. The first example we have is to find the equation of a parabola that has a vertex at 1, 3, and it passes through the x-axis at 7, 0. Well, when starting this process, we have to have an understanding of what is vertex form. And that's why I have it here at the top of our screen. Y is equal to a times x minus h squared plus k. In vertex form, there's 3 coefficients that you have to find or have to pay attention to. And that's the a value, the h value, and the k value. From our understanding and learning of vertex form, remember h, k represents the vertex point. So let's figure out how we can create an equation based upon what they give us. Whenever I'm given information and I have to write an equation, I start what is called a info box. And this info box should not be taken lightly. It really does help you lay out all of your work. So in our info box, we know to create a vertex form equation, we have to have these 3 coefficients or it will not work. So I'm going to write a equals for whatever my a value will be. I'm going to write h equals for my h value and k. And I'm going to read through the problem to see if they have given me any of this information that I need. Because if they give us all 3, we're done. All right, so a value, it will say the a value is. And I'm going to give you a heads up. This is the point of the game. I am trying to figure out what is a. Well, our h value, like I said, this comes from our vertex. So we have to be mindful of what our vertex is. Our vertex is this point 1, 3. So if we line it up with what we have, h is equivalent to 1 and k is equivalent to 3. So all of that came straight from what they told us. Our vertex is 1, 3, h, k. All right. And so for my information box, I know I need an a, h, and k, but all I have is an h and k. So that means they have to give us some more information to be able to write this equation. And that more information that they give us is an x and y value. Looking at the point that they give us, if something crosses the x-axis at 7, that means the x value is 7 and the y value is 0. And this comes strictly from right there, 7 in the x and 0 in the y. All right, so I have done nothing fancy but simply take the information that they gave me and organize it into a information box. All right, now that I have all of my information in my information box, I can start to substitute or replace all of this information into the vertex form of the equation. So let's do this left to right. Instead of y, I'm going to write down 0 equals, I don't know what a is. Looking at my information box, it still has a question mark. So I'm just going to have to write the letter a because I don't know what it is. Then I have this parentheses. This time, I do know what x is from my information box. They tell me that x is 7. Keep writing the equation. It's already a subtraction sign. So let's write that 7 minus and our h value, which is 1. I like to put parentheses anytime I'm substituting a number in. I've expressed that when we talked about evaluating, so make sure that you try to follow along and add parentheses. So x minus h, close your parentheses. And guys, I'm copying, if you're lost, I'm copying straight from this equation here, left to right. All right, there was a little square for my exponent, and then it says plus k. Well, my k value is 3, so I'm going to write plus 3. So being very visual, there's my a, there's my x, there's my h, and there's my k for my information box. All right, so now that we've got this, we have to simplify this equation to try to figure out what is this A value so that I can fill it in my information box. All right, we can do PEMDAS left to right. So I'm going to write out PEMDAS again. I'll just write out PEMDAS for the first example. Hopefully we got PEMDAS down packed by now. All right, the very first step in PEMDAS is to handle our parentheses. And for us, this time we do have parentheses that we can handle. We have this 7 minus 1. So let's rewrite what that looks like once we handle those parentheses. So we have 0 is equal to, I didn't touch this A, so I'm going to bring it down. And this time, 7 minus 1 should give us a total of 6. I am going to keep it inside of the parentheses, squared plus 3. So I did the P in PEMDAS. The next step is to handle the exponent. Our exponent is 6 squared. When you square 6, you get 36. So that becomes 0 is equal to, and hopefully you guys see the repetition. Copy the A down again. If you do not touch it, please rewrite it in the next line of your equation. So 6 squared should give us 36. So we have A times 36, and then we have plus 3. Okay, guys, we did the exponent, but I want to have a little sidebar here. This A36 looks really weird. This looks like I'm playing bingo, like B5. Whenever you're in algebra, the coefficient always comes before the variable. So this is technically 36A. So really no math happened there. You just have to make sure you write it to look like Algebra 1 and not a bingo game. All right, so we have 0 is equal to 36A plus 3. So we have 0 is equal to 36A plus 3. And I am continuing to solve this equation to figure out what my A value is. So the next thing that we're going to do is isolate this A by subtracting 3 from both sides. At this point, once it becomes a solving equation problems, I'm going to address this. It's kind of like you're doing reverse PEMDAS. So I'm coming now and I'm subtracting 3 from both sides. Once you solve, it's reverse PEMDAS. I'm not going to go into too much detail about this because I don't want to distract you. But you guys know how to solve equations. So you hopefully should get my drift that I'm trying to get this A value by itself by subtracting 3 from both sides. All right, the next thing that I have to do if I'm trying to keep and get this A value by itself is I need to divide. So if you're doing reverse PEMDAS or if you're looking at PEMDAS backwards, I subtracted. There was nothing to add, but now I need to divide both sides by 36 to isolate the A. So that tells me my A value is going to be equal to, when you simplify negative 3 over 36, that becomes negative 1 over 12. Now that we have found our A value, let's add that to our information box. So our A is now negative 1 over 12. Okay, at the start of this video, we said that we only need, or we need, a A, a H, and a K, and they're still underlined in red, to complete vertex form. Well, looking at my information box, I do have an A, I do have an H, and I do have a K. This X and Y is no longer needed. It was only needed to help you get started, but we want to write an equation for every X and Y, not just that one. So I'm going to cross it out. I actually like to scratch it out, but I don't want to. There we go. So I don't need that anymore. And so now I'm going to take my information and put it back into the equation. So let's see what that looks like. We have Y equals, instead of A, we figured out that was negative 1 over 12, parentheses, X minus, well, my H value is 1, squared plus K, which is 3. And there you have vertex form of the equation. Everything lines up with the information that they give you. And remember, vertex form has parentheses, so we are done. Okay, let's do another one to make sure we are on the same page and we understand the process. So this time, we have to find the equation of a parabola that has a vertex at -2, -3, And this time it will contain the point 4, comma 1. So always identify what you need for vertex form. The coefficients you need are A, H, and K. So let's start our information box. So if we have our info box, and you don't have to write info box, of course, but I like to write down all of my work to ensure that I get everything correct. So I need an A, a H, and a K. So let's see what they give me. Well, A, they don't give you A. That's the point of the game we're playing, to figure out A. So we're going to put a question mark there because we got to figure that out. But our H value, remember, from vertex form, your first number that you see inside the parentheses is the H value. Remember, it kind of looks like XY. So I had did this on the last video. We have HK, XY. They align. And I think of it alphabetically. X comes before Y, H comes before K. So the first number you see is H. The second number you see is K. Well, looking at what we have, we still need the A value. There's no way I can go straight into vertex form. So they have to give us another bit of information, and that is your X and Y value. What point does it touch? Well, it says it touches the X-axis, or it crosses the X coordinate at 4, and the Y coordinate that matches that is 1. So the point that it contains is 4, comma 1. All right, from here, we can substitute straight into vertex form. So let's see what that looks like. Going left to right, if I don't change something, or if I substitute in something, I'm changing it with the number, sorry. Instead of Y, I'm going to write 1 equals, I don't know A, so A will be left alone, parentheses. Instead of X, well, from my information corner, we see that that is information box. I got to complete the box. We see that that is 4. The equation is already subtracting, so I'm going to write minus. Please be careful on that step. It's already subtracting. Instead of H, I have -2. I am going to use parentheses here. Anytime I substitute, I like to use parentheses and then the square on the outside of the parentheses. And it's calling for plus K. For us, our K value is -3, so I'm going to write -3. Instead of +3, I'm going to write -3 because it is negative. All right, and we are going to simplify this. So whenever we simplify, we remember PEMDAS, the very first step is to handle the parentheses. 4 minus -2. So we have 1 is equal to, the A value does not change. 4 minus -2 will give us a +6. Please be careful with this, guys, especially because there's negative, so I highly suggest you check your work there. And then the -3 did not change. All right, if we're continuing, simplifying, 6 squared will give us 36. So we have 1 is equal to A times 36, and the -3 did not change. Remember I said I don't like to play bingo, so instead of A36, I really want this to be 36A minus 3. And we've done a lot of simplifying here. The next thing that we have to do is to isolate our A value, because we're trying to figure out or solve for A. What we will do is add 3 to both sides. 1 plus 3 should give me 4 is equal to 36A, because there's my 0 pair. And then lastly, if I'm continuing to isolate A, to get rid of the multiplication that's happening in between the 36 and the A, remember that we inverse that by dividing. So I'm going to divide both sides by 36. All right, so when you divide both sides by 36, that will help you get A all by itself. So we'll have A is equal to, if we divide by a factor of 4, that'll give us 1/9. So we can fill that back into our information corner. Our A value is 1 over 9. Okay, originally, remember, we only need an a, h, and k to complete a quadratic equation, so I highly suggest that you cross this x and y out so that it doesn't affect you when you write your final equation. You don't need it. So our final equation will be y equals, instead of a, we know it's 1 over 9. There's a parentheses. X is left alone. Minus a negative 2. So over here we have 4 minus negative 2, and we added it to make 6. Let's keep that same notion. Whenever you see minus a negative, this is supposed to become plus 2 squared, and then plus k. So whenever you see a plus k and your k value is negative, you should write minus 3. All right, and this becomes our final equation. I'm a double checker, so just make sure your a, h, and k line up with what you wanted from your information box, and also make sure you have some form of parentheses because this is vertex form. All right, I hope this video better explains how to write quadratic equations in vertex form when you're given the vertex and a point on the parabola.